Percent is always about the part divided by the whole. Times 100 gives you a number as a percentage. So you know that intuitively. Whether you know it to describe it is a different question. When you do this, and I'm going to beat you with this stick all year long, show your units, show your chemical. Show your units, show your chemical. Show your units, show your chemical. You should show your units and your chemical, I think. When you do the part versus the whole for this, so let's say we're starting with the ammonium chloride. Let's say that my group recovered 0.501, well, we couldn't have that, 5.505 grams of ammonium chloride. I'm literally going to write that because that's my unit and my chemical. Doesn't matter now because you're dealing with one chemical at a time. It will matter. Halfway through the year, we'll be dealing with multiple chemicals at once. You will want to make very certain that you have your units and your chemical. Let's say that I had 12.360 grams total sample. That times 100 will give me my percentage of ammonium chloride in the sample. And yes, I expect you to write that level of detail on your calculations. I'm giving you points for it. I won't give you points if you don't write units and chemical. Or if you just write a number. Like, I did it on the calculator. I know you can do it on the calculator. I can too. But your process is then invisible. So make sure you do that. Now, obviously, these are numbers that I made up. These are not your numbers. I don't know what your numbers are. I know what your numbers should be, but I don't know what they actually are. But you're going to do that for each of the three components, of your sample. The thing that people always want to do then, well, they want to do this. What people want to do is go, oh, well, I got 1.2% ammonium chloride, and I got 36.7%, we don't have iron in this one, but we have salt, NaCl, and I got 42.3% silicone dioxide. So I added those all up and I subtracted the number from 100. Is that how you do it? No. And I will growl and bark and probably drool a little bit and claw at the table I'm sitting at, grading at if you do that. Don't do that. Don't do that. Because what you need to do for percent lost, is figure out what mass of sample. So you're going to take total sample mass minus total recovered mass. And you're going to divide by total sample mass. And you'll multiply that by 100. What that will get you is the percentage of the sample that was lost to you. Now, that's all based on your original numbers. So that's assuming that your original numbers for mass were good. If they weren't, that's a different problem. Do you have questions about how to proceed on that stuff now? Okay, so once you get all your masses, I would invite you, just set your samples in one of the cubbies, probably the outer cubby, because my biology kids tend to be using the inner cubbies for quizzes, though none of them will be today. So set your samples in one of the cubbies and then have a seat, finish your calculations. You can sit with your working groups, and then we'll have a further conversation about percent loss in category, because that's going to be interesting. I'm not awarding points on that, but maybe I'll give somebody a prize.